Okay, Transmath 2 class, we're going to look at the notes for section 2.10. Okay, there's actually 14 sections in this chapter 2, so it's a little bigger. Alright, so in the skills maintenance, we are going to write an inequality statement for each pair of fractions. And so we're just filling in greater than or less than, okay? And so when you do these, you don't have to recopy them. If you want to, you can just kind of squeeze the inequality symbol in between or kind of above. So now in this one, if we have 9/9 compared to 1/2, well, 9/9 is an improper fraction. That's equal to 1. That has to be greater than a proper fraction. So we'd have a greater than symbol. Okay? And so on a lot of these, you can, what you're looking for is one is sometimes improper and one is proper. So 3/6 is less than 6/6 for sure. So we'd put a less than sign there. 3/3 is a improper fraction. That's greater than 1/3. Number 4, 7/3, again, much greater than 1/20. 7/8, that's going to be less than 8/8, obviously. 7/8 is less than 6/6 because 6/6 is equal to 1. 7/8 is less than 1. 3/2, that's going to be greater than 10/10. 3/2 is bigger than 1. 10/10 is equal to 1. 1/5, okay, 1/5 is smaller than 1/2, right? If you cut up a candy bar into 5 pieces and you got 1/5 of that, one of those 5, that would definitely be less than just cutting it in half and getting one of the 2 pieces. Okay, 1/2, that is less than 2/2, and 7/10 is less than 6/6. Okay, complete these multiplication facts. 4 times what is 4? That would be 4 times 1. 6 times 6, 36. Okay, what times 8 is 32? 4 times 8. 6 times what is 24? That would be 6 times 4. And what times 2 is 20? That would be 10. Okay, so in here, what we're going to be looking at is writing more than one fraction, rewriting more than one. So sometimes, like in the previous section, we really only had to multiply one of the fractions by something. The smaller one, you could multiply it by something and make it the larger denominator. Now we can't multiply 2 by anything and make it 5. So this is where we want to think about the least common multiple. And many times what you do in these is you multiply by the other fraction denominator that's there. So I'm going to take the 2 times 5, and over here I'm going to take the 5 times the 2. And so then I'm going to have 5/10 plus, and then this one is going to become 2 times 1, so that's 2/10, and then I would get 7/10 for my answer. Okay, so like we said, we have to rewrite more than one fraction. So a lot of times what that comes down to is, you know, if you have a 5 and a 2, you multiply 5s on this fraction and you multiply 2s on this fraction. That way you'll get the common denominator of 10, which is the least common multiple of 2 and 5. Okay, and this just kind of takes us through the process of how you find that least common multiple, but it's just like counting by 5s and by 2s and finding that, but I'm going to skip going through that process. I think the easiest way to think about this is to, and we just did this problem, so I'm not going to redo it, but the easiest way to think about this is if they're different and you can't change one into the other, then just multiply. You've got a 3 and a 2, multiply by 3 here, and multiply by 2 on this one. And so 2 times 2 is 4, 2 times 3 is 6, so I'm going to have 4/6, and 1 times 3 is 3, and 2 times 3 is 6. So 4/6 minus 3/6, that would be 1/6. Okay. Okay, 3 and 5. So we're going to go times 3 times 5. Remember, it's always the same number, top and bottom, when you multiply and get common denominators, okay? So if they're different and I can't just change the smaller one into the bigger one, you know, I can't take 3 times anything and make it 5, then just multiply by each other, okay? All right, so then we got 5/15, right? Because 5 times 1 is 5, 5 times 3 is 15. 2 times 3 is 6, 5 times 3 is 15, so I've got 6/15, and 5 plus 6 is 11, so I get 11/15 for that one. Okay, so it says fill in the boxes to create equivalent fractions. So if we have 1/10 and we want to create something with a 30 as a denominator, 10 times what is 30? That's 3, and we have to do the same thing, top and bottom. So 1 times 3 is 3, 3/30. That would be my equivalent fraction. So what they're saying is 1/10 and 3/30, those are the same value. but they just look different. And sometimes we need to make them look different so that we can add or subtract with another fraction. Okay, 2/3, and we want to change it so that it has a denominator of 9. And so 3 times what is 9? 3 times 3, and again, same on top and bottom. So 2 times 3 is 6. So 6/9, 2/3, and 6/9 are equivalent. Those are equal, right? Equal fractions. These are equal. All right. Okay, so applying some skills here. So we're going to fill in all these boxes again. So 8 times 2 to get 16. Same thing in the top and the bottom, so that's 2/16. Next one, 5 times what is 15? That would be 5 times 3. And so then we get 12 over 15 there. And next one, we got 3 times what is 15? That would be 3 times 5, so we have to do 5s top and bottom. So we get 6 times 5 is 30. And next one, 2 over 3, so we take 3 times what to get 9? That would be 3 times 3. 3 in the top and the bottom, so 6/9 and 2/3. And I think we already did this one, but so times 3 times 3. 3 over 30, same as 1 over 10. Okay, so I kind of wrote a note here because there isn't a lot of space, so I kind of made more space on the next slide, so we'll do these in the next slides. Okay, so 1/8 plus 3/4. Well, if we ask ourselves, can I change a 4 into an 8? Yes, I can. I can multiply it by 2. So then we only have to, change one of the fractions. So 1/8 can stay 1/8. And the next fraction is going to become 3 times 2 is 6. So 6/8. So 1/8 plus 6/8, that would be 7/8. Okay. This one, can I change this 2 into a 6? Sure, if I multiply it by 3, right? And so I can rewrite this as 3/6 plus 3/6, right? So this fraction also became 3/6, 1 times 3 and 2 times 3. Now I can add those together and I can get 6 over 6. Okay, next one, can I change the 4 into an 8? Yep, if I multiply it by 2. So multiply by 2, top and bottom, 10 over 8 minus 1 over 8, and that would be 9 over 8. And this one we already have common denominators, no need to worry with that one. So 5 minus 3 is 2, so I get 2 over 4. Okay, this one now, 3 and 2. Can I change that 2 into a 3 by multiplication? No, I cannot. So this would be one where we have to change them both. So I can change them both into 6. If I multiply one of them by 3 and the other one by 2, then I will have 4 over 6 for this first one, and I will have 3 over 6 for the second one. Now I can subtract. 4 minus 3 is 1, so I get 1 over 6. Okay, these already have common denominators, so that's pretty easy. 4 minus 3 is 1, so 1/3 for that one. Okay, part G, 9/5 and 1/2. Can I change the 2 into a 5 by multiplying? No, not really, I can't. So I have to go and change both of them. So if I multiply by 5 over 5 and by 2 over 2, then I can say that this one is 18 over 10, and that this one, 5 times 1, 5 over 10. And then I can take 18 minus 5 and get 13, and the 10 stays the same on the bottom. Okay. And part H, 2/5 plus 1/4. Can I change 4 into 5 by multiplying it by something? Nope. And so again, and that's the case, let's just multiply this one by 5 over 5 and this one by 4 over 4. That way we'll get the same denominator of 20, right? And so 4 times 2 is 8, and 5 times 1 is 5, so I've got 8 over 20 plus 5 over 20, which is 13 over 20. Okay, and that is all. That's everything. So we did a few. The new thing was just where we had to change, both fractions. But like you can see, when that's the case, when you can't just change the small one and make it into, I can't multiply 2 times anything and make it 5, then you just say, well, if this is a 5, to get a common multiply, just multiply 5 and 2. So multiply 5's here, multiply 2's here, and then you get your common denominator. All right, so that's it for section 10.